Okay, so let me share my screen, and I'll just briefly talk, and then Stefan, you can chime in. So just our proposal is just to let everybody know that we've been doing this collaboration. FutureWay has been doing this collaboration as part of this collaboration. We're working with the TUVN researchers. So this is essentially SLO cloud project. So what we want to do is we want to incorporate this work. Currently, it's on GitHub. It's open source. It's licensed Apache 2.0. And we want to incorporate this project as part of Centaurus itself. And it's a pretty, powerful concept, actually. See, if you, so essentially what this project does is, so you guys can see the GitHub? You can?
Yes.
Okay,
yes,
perfect.
I can see it.
Perfect. So,
Yes.
so this project, what it does, it makes complex SLOs as first-class citizen by enabling multi-dimensional SLOs. Typically you will find, the cloud providers, you can define your SLA in terms of how much CPU, how much memory, and all the just basic resource level SLOs. So what we are doing is, as part of this collaboration, we're extending that to make it multi-dimensional. That not only includes resource dimension, but the cost and the quality as well. So the user he doesn't even have to say how much CPU, how much memory. He can just say, I want 99 point, whatever the availability and the latency in terms of that. So the quality dimension, basically. So that's and then this whole thing. And this SLO construct is kind of wired in as part of the cloud itself. So it becomes a first-class citizen. So at the very high level, I'm going to let Stefan just kind of briefly talk about it. But we call it SLOC, and we renamed it to Polaris later on as well. So SLOC, what it means is service level objective for next generation cloud computing. So, what the project includes things such as the SLO script. So we built out a brand new scripting language, kind of a DSL, for this framework. By using this DSL, you can develop complex SLOs based on one or more metrics, okay? And you can define custom metrics by aggregating other metrics. So it's more like a coarse-grained metrics definition. And then you can configure these SLOs using SLO mapping. And then another key thing to highlight is that we're using predictive analytics to do the proactive scaling, you see. So it's not just the reactive. So we do reactive scaling as well. But in it, the key thing to highlight is in addition to reactive scaling, we do predictive scaling as well. So we're using, the deep neural network transformer framework, and we're using LSTM to do that. So, and finally, the key thing is the elasticity strategy. For example, if you're familiar with the Kubernetes HPA scheduler, it does a horizontal, it's called horizontal part autoscaler. So one of the key things what we have done is, as part of this collaboration, so in this, as part of the elasticity strategy, you can mix and match, I think. So you're not just bound to one type of elasticity, such as horizontal or vertical. So you can do mix and match. So we provide horizontal, vertical, and a combination of both, basically. So it's a pretty generic framework. So we have abstraction and decoupling at various levels. So nothing is kind of hard-coded. You can plug in any kind of metrics, and you can define different type of elasticity strategies and all that. So that's kind of a high-level description. And Stefan, he's the key lead researcher from TUVN. So I'll let you just say a few words on this project. Go ahead.
Thanks a lot, Deepak. Just let me quickly.
You want me to share? Stop sharing?
Yes, please. I can share my screen, and I can just quickly walk you through. I do have some slides, but I think actually you really covered nicely the ground on a high level, so I can skip a lot of these things which we have here, and maybe go directly to maybe here. Do you guys see my screen, by the way?
Yes, yes, we can see.
All right, perfect. So I will just quickly show you an example of this high-level SLO definition, which is shown here at the bottom of the screen. And I think Deepak really did a nice overview. And one of the main things is that we are trying to enable users to specify high-level requirements or high-level metrics which should be fulfilled by a specific workload. So, for example, here you can see that okay, these are some checks, some kind of sanity checks that everything works nicely, but basically these two lines here are enough to specify the SLO controller. And if you can notice here that we are working with a high level metric, which is called cost efficiency. And to calculate cost efficiency, you take you basically need to monitor the resources, but at the same time you need to monitor the costs, obviously, of the system, and then you can calculate cost efficiency. So how cost efficiently is my application or my workload running at the moment? And that can be directly, as a first-class citizen, used in the SLO specification without having to figure out how to convert all of these low-level things into high-level, more of a, let's say, KPI leaning SLOs. And then the SLO controller periodically will evaluate these input metrics which are provided, so be it high level or low level, but obviously high level are more desirable. And then it can trigger a user configured elasticity strategy. That would be, for example, the simplest example of elasticity strategy would be scale out or scale in. So spin up additional container or spin up additional VM. So that's just a very, very basic elasticity strategy, but we do, as you will see later, we do support specifying and designing very complex elasticity strategies. And basically, the whole point is that the evaluation loop of the SLO controller monitors the metrics, which also continuously monitors the metrics which are specified, and then triggers elasticity strategies um, when, for example, an SLO is violated. And to specify an SLO, we only have to specify the SLO, so the service really level objective business logic, as again shown in our example here. In addition to this, so to these elasticity strategies, we also offer, let me just show this slide, we offer compose metrics. So we offer Kubernetes controllers, basically, which can be used to aggregate low-level metrics and then create these compose metrics. And this here you can see the very high-level overview of this process, how it works. And I don't want to go into too many details here, but I will show you the demo because we also developed a CLI which enables working with the framework easy or it lowers the barrier of entry, definitely. And here you can see that our framework or our controller, which you can see here on the right-hand side, they basically they calculate and expose the metrics to Prometheus, and then the metrics is exposed to the cost efficiency, for example, in this case, cost efficiency SLO controller as a Prometheus metric. So it's currently what we use as a communication system or communication backbone, but obviously the framework is generic, as again mentioned before, and we can exchange Prometheus for any other communication backbone, or for example, any other time series database. And then I will skip these things here because Deepak did talk about them, but I will show you the demo of how to create a Polaris SLO mapping and an SLO controller. I hope you'll see what's happening here. So here we are now initializing a new workspace, and if you're familiar with, typical CLI controllers, we're just kind of generating a new workspace and generating a lot of boilerplate code. Here we have to, this is all auto-generated, what you see now, and the users have to just add several things, such as change the API group to create the actual SLO mapping. And then in the second step, we want to actually generate the controller itself. So we can install a compose metrics library. These are basically the libraries which are there with the metrics which we already support. And then again here we can just perform some simple configuration and proceed with the implementation of the generated SLO controller. And yeah, now we are already building and deploying the SLO controller. Sorry, just stopped. Wanted to remove this thing so that you can see it better. Okay, let's go here. Yeah, and now we are creating the elasticity strategy controller, which is basically how we enforce SLO compliance. Again, there is this, a lot of auto-generated boilerplate code and a clear description how we want, what needs to be done in order to configure this for the custom purposes. Or we also offer a boilerplate controller, which is basically, yeah, you can see it like a, let's say, an abstract class or something which already has a lot of things pre-configured, and it's rather opinionated controller, which is easy to extend. Fine, now we're building it as a Docker image, and here we can see how the controller is triggered and how we can actually, how we enforce the mitigation, or how we enforce the SLOs. And finally, yes, the important thing which we haven't really talked about is that the metrics themselves are not only, we also support the predictions. So as Deepak said, we developed two models, one based on LSTM and one based on transformers, which are used to predict potential future violations of SLOs and trigger these elasticity strategies in advance in order to actually prevent any violations, and hence increase the compliance with the percentage of compliance with the SLO. So I think this was the overview. If you want, we can go into more details of particular subtopics of the project. Or if you have any other questions, I'll be glad to help answer them.
Just a few things I want to add. Actually, this is SLO-based cloud computing is going to become more and more important as we go forward, especially the way cloud is changing in front of our own eyes, towards the distributed cloud. And there's already been discussions, and there are a bunch of companies coming up, and this whole cloud marketplace concept basically. So essentially, what that means is a user say, I want to deploy this application. He doesn't care, as long as the SLA is met, it doesn't care. It gets deployed in AWS so that there's been actually, that's a topic for some other time. But I think that's the direction cloud is going in. So you can imagine, and one of the key things which Stefan and his team has done is that's the whole decoupling actually. So it's not just tied to Kubernetes. For example, if you're running ECS container, for example, you see underneath your cloud is AWS, and you're using their containerization. So it's pretty decoupled. So we can easily plug and play and do the SLA enforcement, in any type of underlying cloud infrastructure, actually, AWS, Kubernetes, or whatever. So that's the
Speaking of this, Deepak, if we run this on top of Arctos, do we need to change anything, or it already works with Arctos since it's based on standard Kubernetes CRD mechanism?
Yeah, that's a good question, Xiaoning. And also, as just to come back to the previous point, yes, these are, as you can see here on the left-hand side, these are the Polaris concepts, which are high level and generic. On the right-hand side is a current implementation based on Kubernetes, but that can be done also, for example, on OpenStack or on Arctos. However, I think that the plan for I don't know now from the top of my head, but I think it's based on a slightly older version of Kubernetes, and we do have some features from Kubernetes in the current implementation.
Oh, I see.
But there is a plan to do the merger with to merge basically with the upstream. So I think that basically once Arctos is rebased, so to say, on the latest Kubernetes, then it will work out of the box for sure.
Okay. And the other thing to keep that in mind, the multi-tenancy may throw some curveball at us as well. So
that's fine. Multi-tenancy now it provides a kind of transparent support for CRDs. We support system level output talent. It's you don't need to change the CRD's definition of controller.
That's good to hear. That means that I mean, I'm not so intimately familiar with the ins and outs of Arctos, but as you know, based on our previous discussions and all the following up with the development of Arctos, I'm not familiar with any major let's say roadblocks to be able to port this to Arctos as well. Having said that, again, it would be needed to rebase Arctos on
I guess that's probably the major thing. Some version difference. Other thing, if it's pure based on standard CRD and the controller mechanism, should work on Arctos.
Yes, exactly. It's a very simple specification in the sense we haven't really done any particular work on the CRDs themselves, but what we do is, and exactly that's seen here. So for example, we have SLO mapping and elasticity strategy type. So all of these things are specified with our DSL, so domain specific language, which then gets compiled in CRDs for the purposes of Kubernetes. So these are all auto generated standard CIDs for the Kubernetes, but then again, we can use that also for some other infrastructures.
Great.
Another thing I wanted to mention, I know Xiaoning is he was very intimately involved in this project, but for other people, so Stefan's team did a lot of research. The DSL, which we keep talking about in this project, is built around TypeScript actually. So they decided to use TypeScript, which seems to be getting pretty popular actually, especially with the WebAssembly and all that. So I think that was a very good choice actually. So now, the more I think about it. So that's another thing. Yeah.
Definitely. Thanks for mentioning that. And also, we are planning to do some contributions to Kubernetes space itself, because we are the first open source project which has a Kubernetes CRD generator in TypeScript. So this is again similar to the previous point which I made, that we have our own language which gets compiled into CRD, or which then we have a generator which can produce CRDs, and our DSL is in TypeScript. And for those reasons, we actually had to do the CRD generator for TypeScript, and we are actually the first ones out there. So this will be also one of the contributions to the Kubernetes directly, or to the Kubernetes open source.
Yeah, because more I think about it is, even though the focus in this project is SLO, I think that by choosing TypeScript as the underlying pretty complex, very flexible language, I think we can do a lot more than just SLOs actually. So maybe,
Yes,
you know,
probably.
so this could possibly become a POSIX of cloud APIs. Who knows? So yeah, POSIX interface for cloud API.
Definitely sounds
high level
possible.
policy language.
Yes, yes.
Yeah.
And also, you know, the user base is quite broad, which is obviously very interesting and good. So because yes, we are trying, and I mean for those reasons also we have our CLI so that we can actually lower the barrier of entry for the new potential contributors, so that people can actually easily contribute to the projects. In addition to that, I forgot to mention that as well. I think it might be interesting. We are trying to follow this DevRel first approach, which means that we are really kind of trying to put a lot of emphasis on the developer relationship, and for that we developed a set of it's basically a set of development containers, meaning that all you need to do to get started with the project is you just need to pull a Docker container, which then integrates nicely with the VS Code. At the moment, we are just integrated with the VS Code IDE, and literally you can start within 3 minutes. Like have everything ready on your local workstation and start, you know, potentially writing code within just really a couple of minutes, which is obviously very interesting and very important for any open source project, since people, you know, even if they want to have a look, this is something very convenient and can help attract hopefully a larger community to the project.
Yeah, I'm seriously, I didn't joke actually. There's been a discussion going on to come up with a POSIX-like interface for all clouds actually. So it's essentially the cloud marketplace thing. So the user just uses one API, and then behind the scene it automatically. So we'll talk. I'll talk to you about that. There's been kind of discussion going on.
It's interesting.
Yeah. Could you share the link?
Oh, for that?
Yeah, for them, just similar, very interesting idea.
Yeah. Because I think that's the industry. Because I think you guys were not there. This all came out of there was a Rise Lab conference a month ago.
I remember what you are talking about.
Yeah. So I think it's not just that actually. It's not just in academics. Actually, there are companies coming up. You know, there are 3 or 4 companies. A company called Cast.ai, Spot.io. So essentially, they take your workload and they say we'll manage and we'll give you cheaper price than Amazon does or Azure does. And behind the scene, they keep moving from one Spot instance to another Spot instance. So the user doesn't know about it actually.
Yes,
it's like a cloud arbitrage.
Yeah. I'm telling you,
that's
this
also
is the
one of the scenarios that when for the cluster federation.
Exactly.
Yes.
So the whole thing, you know, is, you know, you have a POSIX interface, one API, and then you have a federation layer underneath it, and then you have peering. You know, Stefan knows what internet peering is basically. So when you move your across, you know, just like internet does network peering, so there needs to be a cloud peering as well. So that currently none of that exists.
Now the problem is if we try to move the workloads on the IaaS level, purely resource like VMs or containers, that's not difficult. But if once your workloads start using PaaS services, like some cache service or MySQL service, especially when you use some proprietary feature provided, then you are trapped. You won't be able to. It's very difficult to move.
Well, migration, I think so. That's where, if you think about it, so the bandwidth becomes the issue because you're moving big, heavy service across clouds, for example.
Yeah, I mean, once you start using some proprietary service or features.
That's always going to be the problem. I mean, So it's not that marketplace is going to replace everything. So, but the customers will have a different option now. You see, as opposed to being logged into AWS. If I'm, you know, because we can discuss.
We can discuss it later.
I'm going on a tangent, but I think
for this Polaris Cloud, just want to see if anybody else has any questions. By the way, great presentation from Stefan. Thank you.
Thanks.
Like I see Huang Ying online. Huang Ying from Actos side. Huang Ying, do you have any comments from Octo side for this project. Hey, okay.
Hey, sorry, I was muted because I was previously driving. So so I'm more interested to see how this can be cooperated. I mean, how can we start using it, and how it gonna help that I mean, is there a plan that you're gonna sorry, it's actually our responsibility. So if we plan to use that, it's better that we will have to try to incorporate that and comparing this, say whether it help us to compare Actos with actually Kubernetes. So if there's no difference, which is good, but if there's a difference, it actually help us to improve.
I think this project builds on top of at the moment Kubernetes, but it is also possible to to port the project and run it on top of Arctos, or at least it will be possible in the future once we do some changes, or once the Arctos gets let's say upgraded to use the latest Kubernetes. So I think it's not really.
What's your which is the version of the Kubernetes you're based on? Is that has a requirement or not?
It's not the hard requirement, but there are some features which we are using which are not supported, and I think Arctos is based on something
115.
like 115. Yeah, I'm not sure.
115, and we ported a lot of performance impacted the commit into Arctos, but not any features. We did not particularly port any features. So if you have some kind of a list of the feature that you are dependent on, we can evaluate and see whether we can spend some time and porting those features and try it out.
Okay, that's definitely a good point, and I think also there is some work being done internally, or at least it's on the roadmap to update Arctos to even later version of Kubernetes. But I think it's important to realize that this is not let's say it really builds on top of Kubernetes, and it's not a battle between Kubernetes or Arctos, or we are not trying to claim that one is better or the other. We are simply sitting on top of any, so conceptually speaking now, on top of any infrastructure or on top of any infrastructure.
I understand, right? I understand.
And we are trying to manage them.
Ideally, you want every infrastructure to be able to pick this up, right? It's not just based on one infrastructure such as Kubernetes. Of course, it has been used widely. That's why you choose it.
Exactly.
But the essential goal is it's better to be incorporated into any like a big adopted infrastructure, so that it can help them to improve, right?
Yeah, I think one of their design goal is to get decoupled with the other.
Right.
Exactly.
So that's why if you're using some particular feature, you probably want to list them out and say whether is that how it make it difficult to be incorporated with other.
That's a good point, Ying.
I think there is a slight misunderstanding here. This is not the feature which we require from the infrastructure itself. On the high level, so on the generic conceptual level, which we are working on, we don't care about the underlying features. However, we do have, as shown here, for Kubernetes, we have a specific implementation which is based on Kubernetes, right?
Yes.
And these are, you can see these as connectors. And then if you want to run this project on top of OpenStack, you would need a set of connectors. However, since Kubernetes and Arctos are so similar to each other, we don't want to run separate connectors for Kubernetes and for Arctos. And here is this kind of missing feature, let's say, or compatibility issue. It's not on the on the conceptual level or on the high level of the framework. It's in this specific connector or specific implementation for Kubernetes. Does it make sense now? So basically,
I'm a bit out. So here, where you have a comparison between the Kubernetes Polaris and the Kubernetes. So you're especially you're using like a CRD. My understanding is you using some special in Kubernetes like CRD and some kind of other controllers. I'm not sure about what you're talking about, the custom Kubernetes controllers. Do you require some special controllers in Kubernetes?
No, the custom Kubernetes controllers are essentially developed by us.
Operator.
It's like operator.
Just
yeah, but
yes.
how are you embedded into this Kubernetes? Are you making changes to the Kubernetes controller code? I mean, adding a new controller in their
no.
collected
it's
system,
just the
or it's
typical,
just a standard noun process?
It's it's just the typical CRD plus operator pattern. It's all like plugin style, doesn't require Kubernetes self code changes.
But
yes, exactly.
where is this plugin is hosted? It's like automatically
running as containers
by CRD.
So we have let's take example of the SLO controller, right? And this is the high level concept which is developed and provided by Polaris project. And you can see here an example of how you would write an SLO controller. And here you see there is no dependence on Kubernetes, Arctos, or any other cloud infrastructure. You just use some TypeScript code, and you only write as noted.
It's okay. It's okay.
I need to go.
Is there standard noun? Is there standard noun process, or it's actually can be injected into Kubernetes container without interfering with?
I'm sorry. I need to go, guys. So I think from my side it's approved. So I need to go. So I think you guys can go ahead and vote.
Yeah, Moni, can you quickly help make a vote for TSC members?
Yeah, I need to go. Actually, I'm already late. I didn't notice that.
I think we can probably continue the discussion offline on the email with Stefan for this if you have some question want to clarify.
Sure. Okay.
So thank you.
Definitely.
Because Deepak is going to leave, we have to make the vote before he leaves.
Let's do quickly. Mangni, you want to do that quickly?
I'm doing it.
Hey, Moni, are you there?
Yeah,
I'm doing it.
Okay, thank you. Yeah. And also, I got the email reply from Prisha, and obviously he's in the Linux con today, and Deepak, so he said that he cannot make the talk.
Yeah, I saw that.
Maybe next time or sometime later.
Yeah. Yeah, I didn't notice that. I had a meeting at 8:30. Shoot. Okay, I got it.
Oh, by the way, Stefan, are we developing any other collectors now? I mean, for other systems? Just curious.
No.
Okay.
No.
Okay,
there's a lot of work.
Yeah, I can imagine. Yeah, I can imagine.
Yeah. At the moment, we're just based for Kubernetes/Arctos.
Hi, Stefan. I actually in between I got disconnected. I have one small question.
Oh yeah, go ahead, Sammy.
Yeah. So whatever controllers you mean to say, I think you were discussing about operators. So is it a typical Kubernetes operators and CRDs?
I think I think I do see a lot of the differences between controllers and operator pattern, but yeah, for the sake of this discussion, it's you can think of this as an operator or as an controller plus a CRD. So what we do is basically we have a mechanism which automatically produces CRDs from the specification in the in our domain specific language. So that's one side of the story. And then as this connector, we have basically a specific implementation or auto generation of Kubernetes controllers. And that's what you were able to see with our CLI.
Okay, so in that case, there is no deployment. Basically, the deployment, it is like Kubernetes native, right? The APIs.
Exactly. Exactly. Yes. There is no you are not required to have any to make any changes to the Kubernetes. The only thing which you do is you deploy additional you deploy essentially additional container or additional pod in the Kubernetes, which is essentially a controller. And on top of that, you also need to obviously provide and specify the CRD. But that's all also supported, or that all can be done through our CLI. So you don't even have to, go directly and work with Kubernetes if you don't want to do that, or if you want to do that, you can use kubectl or anything as such.
Okay. Yeah, thanks.
Thank you.
And Moni, did we get the result?
I don't know who actually voted. So because I had more.
You cannot see the name.
Yeah, I can't see the name. So
but it's a yes from my side, and Deepak also mentioned that he had a yes, and Stefan.
Yeah, I also did it.
Sania, you also vote approve, right?
Yes.
Oh, great. Then we get 4 votes. We will update this in the meeting notes and announce this. And Stefan, I don't know if we already discussed with Deepak or not. Do we want to move this repo physically? I mean, to the Centaurus organization.
That's a good question. We were just briefly mentioning that, but we haven't really reached any verdict, so to say. It might be pragmatic to do that, let's say, towards the end of the year, maybe, because we are now preparing this version 2 release. So this would be like, the project actually is officially ending at the end of the year. And we still have some things which we want to deliver and polish the repository. But I mean, yeah, let's maybe let me maybe also check internally with the team what we need to
Yeah. I'm just checking. I think it's a decision up to you, between you and the Deepak, the two sides, TON and the feature way to decide.
Yeah, but that's definitely something which what we already considered. We just need to kind of figure out the details so that we don't do like the same thing twice, essentially. So just to minimize the extra work. That's it.
Should be. That shouldn't be dependency. I mean, in the past we moved several reports. Looks like straightforward.
Yes, but there is the documentation and some links, etc. Because we already did renaming of the repository once, and then nothing worked. I mean, the code worked obviously, but the whole documentation, the demos, and everything were just like a whole mess. And we did that once already. Don't want to do it again if it's not like if it's not the final thing. That's what I'm trying to say. But yeah, definitely, it's on the roadmap, and it will be done, in the next couple of months.
Great, thank you. And I think that's today we already had the first topic, and for the second one, it's going to be a talk from Prishan, but because of the conflict, Prishan cannot make it today. So we have only one topic today. Before we finish the meeting, anything else we want to discuss?
I just want to say, Manny, Rupal, Prashant, and Dr. Sean, and the gang did very well yesterday at the OSS event. We had a 1-hour tutorial, and I watched the tutorial. It was really good, well organized, and they did an awesome job. Especially Manny. This is your first time, right? It was really good. So I was really impressed. So yeah, kudos to the team.
Yeah, congratulations. Yeah, Sania.
Yeah, I have just one thing. That do you know the project Karmada?
Yes, I heard of it. Yeah, heard of it.
This is from Huawei.
Yes. It's
a Huawei project. They are open.
Right.
They've open sourced it, and we don't know FutureWave. To be honest, we don't know anything about that project. They just asked us to put their logo on our banner. But if you go to the OSS event, they have a virtual conference. and they have experts there who can explain that project to you.
Yeah, actually, I am in touch with. I think it is coming from Kevin. So we work
Correct.
with Kevin.
Kevin
Yeah,
and
Kevin.
Mada, you can
No,
reach
my question is that uh, uh, do we have any similarities between Centaurus and Karmada? Because that also is taking care of multi-cluster orchestration provisioning, but it is more of Kubernetes native.
Yeah, I know.
I was just seeing the architecture of both of these projects.
Yes,
So
in the Centaurus, we have a project on the edge computing. I know in the past, in several months ago, they had several discussions with the Kamada team discussing the difference and the similarities. Also the feature support, like in which situation should we use which architecture. But I don't know what are the conclusions they reached before, because at that time I already left the company. If you want to know details, you can reach out on the feature side. You can reach out to Peng Du.
Yeah.
On Huawei side, you can reach out to like Kevin or Mada.
yeah, Kevin. I am in touch with Kevin because we are discussing with respect to Karmada data management part, whether Soda components can be used. So we just initiated some discussions.
Yes, because Kamada does share a lot of similarity with the Edge project in Centaurus.
Yeah, that's right. So probably if it is something similar, there should be. I mean, it's better we have some collaboration so that, because what I understand is that Kevin was telling that they are going to put it to CNCF Sandbox project.
Yeah, that's also what I heard.
Yeah.
Yeah. Well, we can find out more about it and see if there's a synergy with the Centaurus.
Exactly. I mean, rather than competing.
Yes.
No, it would not compete. I mean, I think Kevin should be aware of Centaurus very well. So I don't think he would be doing something that would compete against Centaurus. So it could be very complementary. Maybe some overlap. I don't know. But yeah, but that's an open source. I just didn't know it's going to be donated to CNCF. So we need to investigate that. Yeah. So, another thing I want to mention is so I just found out that Open Infrastructure Foundation is a member of SODA. And
Right.
so I asked Dr. Sean, I said, hey, Centaurus should be a member of SODA as well. And he said he agrees. So I reached out to Stephen Tan, who is the chairman of the board. I said, we want to also join. So I just want to let you know that it's in the process. So we'll be a member of SODA. So that means in the future, whenever SODA is doing an event, because they seem to have a lot of money, so they do like Soda Con and stuff like that.
Right.
We should also have presence there, because I think their ecosystem would be our ecosystem.
Right. I think we are open, very open. Okay. I think I hope you saw, I mean, Soda booth maybe at OSS.
Oh yeah. They are there. In fact, I told them that we should cross-reference. So we have included Soda because Soda is a member of Centaurus, right? So I told them that we should cross-reference. Yeah.
I think it's cross-branding is the best way to improve the ecosystem.
Yep.
They will benefit each other.
Okay.
Yeah. So maybe you can reach out to me and Steven, so we can take it forward.
Sure. Okay. I'll connect you too.
Yeah. Sure. No problem. Okay. Yeah. Thanks.
Sounds good. That's all I have. Thank you.
Thank you. Okay, if we don't have any other topic, that's all for today's meeting. And Huang Ying, looks like we have 10 more minutes left. If you still have something you want to discuss with Stefan, maybe we three can leave on the meeting if we want to finish the discussion.
Sure. Thank you.
Okay. Thank you. Bye-bye.
Definitely.
Okay, bye.
Okay. Thanks, everyone. Bye-bye.